Salam and good day, Doctor. We are from Group 8, Section 3 for subject Hydrology. Our project title is about hydrology methods and the subtitle is Unit Hydrograph. Our group members consist of Wu Yuting, Tan Min Kai, Lee Change, me, Victor Yong Wei Tek, and Ken Min Chu.
My name is Wu Yuting with metric notes at F200155. Today I'm going to present about the introduction. What is hydrograph? Hydrograph is a graphical representative as a runoff due to it change over time at a specific location. The area under the hydrograph is represented as the volume runoff, which indicates that the time distribution of runoff at measured or calculated point and a single curve reflect the complex characteristic of watershed. Also, a hydrograph is built up with certain components such as rising limb, recession limb, lag time, and peak discharge. Rising limb is indicate that the flow from the catchment area is increasing in response to the rainfall, while the falling limb is a continuation of graph from the peak flow rate. Peak discharge is the highest point on the graph at which the flow is greatest, and the lag time known as the time between the peak of precipitation and peak of discharge. Subsequently, hydrograph can be categorized in different types such as unit hydrograph, natural hydrograph, dimensionless unit graph, synthetic hydrograph, and dam bridge hydrograph. In our study, we decide to use unit hydrograph as our method to calculate the runoff surface. There are several assumptions and limitations for unit hydrograph. First, the effective rainfall is occur uniformly within the drainage basin and its specified duration, which means that when a short period of storm is selected, a well-defined single peak of hydrograph with uniform effective rainfall will be generated. For second assumption is principle of time invariance. Principle invariance means that the hydrograph of direct runoff resulting from a given pattern of effective rainfall will remain constant. Another assumption is the hydrograph of direct runoff with same or constant time base will produce the effective rainfall of equal duration. For limitations, a unit hydrograph is suitable for any size of drainage basin in theory. However, when the area of drainage basin is larger, will cause the uniform distributed effective rainfall rarely to occur. It can be concluded as the bigger area of drainage basin will less fulfill the assumptions of unit hydrograph. A unit hydrograph will be also limitations when the significance of amount of storm precipitation fall as snow. It is due to the snow will melt is generally influenced by the temperature change. In addition, the unit hydrograph may not function well when the snow is surrounded at the drainage basin area. It is because the storm rainfall may mix up with the snow, affecting the delay of runoff occur.
Hi, I'm Victor Yong Wei Tek, metric number AF200134. In general, synthetic unit hydrograph is used to determine the peak discharge in order to design the hydraulic structure such as dam, sluice gate, and weir. These actions are to prevent a natural disaster to occur, such as the flash flood. According to Rosmalinda, the case study is done on the upper Comorin of South Sumatra in Indonesia. The average precipitate is about 2,600 mm² in a year. The climate is between 28 to 32 degrees Celsius. The dry season is from June to September, and the wet season is from October to May. Most of the time is the wet seasons, and the last one is the catchment area is about 4,260 km². There are three types of synthetic unit hydrograph that commonly used in Indonesia. First, the Soil Conservation Service dimensionless unit hydrograph. The second is the Cinder synthetic unit hydrograph, and the last one is the Nakayasu synthetic unit hydrograph. Table 1 shows that the characteristic of the catchment area that require for the synthetic unit hydrograph. The characteristics such as the catchment area, the runoff volume, peak time, and the base time. The peak discharge that obtained from all methods are tabulated as below. There are minor errors between all methods, and the errors can be negligible. As a shining example, the peak discharge that obtained from the SCS methods and the ITB1 methods are slightly similar. Therefore, the errors can be negligible. A graph of discharge again time is plotted, which is the synthetic unit hydrograph. As we can clearly see that the shape for the synthetic unit hydrograph for all methods are the same, and the peak discharge are slightly similar for all methods. In conclusions, the peak discharge is easy to obtain by using the synthetic unit hydrograph because it requires less data. The recommendation of this study is using the different type of the soil in the future case study. Different type of the soil can change the discharge of the fluid. This is because different type of the soil consist different permeability. Therefore, the catchment areas which always flooded can be used in the future case study to enable the soil can absorb the acid rainfall to avoid the flash flood.
A very good day to Dr. Zarina. My name is Keminju Anakin Hamude, matrix number AF200118. So now I'll be presenting one of the comprehensive review, which is on the rainfall threshold of Cytherean River flood for early warning on the urban area in 2021. So this research has been done to obtain the unit hydrograph of Cytherean River. So the method used in this research is the deconvolutions method and coefficients of drainage that being calculated based on the study area. And also the convolutions method is used in this study as the observations unit hydrograph method. So from the result obtained, the threshold rainfall in Bojong Sawang is the lowest, which indicate that the Bojong Sawang is the most endangered district for facing the flooding issues.
Alright, so next will be the recommendation part. So one of the recommendations is to improve the performance of synthetic unit hydrograph by adjusting the model parameters in order to predict the flooding happens in future. So its advantage is to decrease the deviations of synthetic unit hydrograph model parameter in terms of its peak discharge and also an average of peak time, which is up to 30%. I think that's all from me. Thank you.
Hi, my name is Yichensh. My matrix number is AF200168. A study about the deconvolution of the flood hydrograph at the outlet of the watershed Kolondiba in the south of Mali in 2012. In order to know the runoff process, the deconvolution was made at the outlet of the watershed, which is about 3,050 km square. To determine the origin of the runoff, there are three floods were selected during higher water periods. While the EMA diagram of EC and TDS is linear during flood and drying up at the moment. The mineralization occurs at the outlet during the drying up period. The cycle shows that the EC are the same for a given water level, thus the selected traces to fulfill the aforementioned deconvolution are better. For the recommendation, a circular drainage basin have a shorter lag times and higher peak discharge. Next, the water can flow more quickly on the steeper slopes. And lastly, the drainage basin have many streams, tend to have higher drainage density in order to drain more water quickly. That's all from me. Thank you.
Welcome to Doctor. My name is Uyu Ting with matric notes AF200155. Today I'm going to present about the comprehensive review that case study on Bengawan Solo River in Indonesia. The purpose of the research is to identify the best discharge of peak effectiveness of surveillance of by using several methods such as synthetic unit hydrograph, soil conservation service method, SUH of Nakayasu method, and SUH of Gamma 1 method. In this research, the analysis of flood discharge from field observation will use the water level from the data recorded at the Serena Automatic Recording Level Station AWLR on the Bengawan Solo River. Usually, the length of the Bengawan Solo River from upstream to the Serena AWRR station is about 37 km. And also, the area of the Bengawan Solo watershed is about 951.35 km square. Table 1 shows that the result of maximum flood discharge of each method and the flood discharge at Suriname AWRR station. By referring to the result from the Table 1, a synthetic unit hydrograph can be generated as shown in Figure 1. From the synthetic unit hydrograph as shown in Figure 1, it can be concluded as the Gamma 1 method is optimal synthetic unit hydrograph for calculating the maximum flood discharge at Bengawan Solo River. This is because the result of the Gamma 1 method is closer to the on-site observation flow rate and the error is lowest, which is at 0.0%. Next, I will present about the recommendations. In order to improve the unit hydrograph shape, there are several factors that should be concerned. One of the factors is design of flood. The design of flood is usually related to the size, capacity, and the age of the water resource structure constructed. For example, the design of drainage is small, it will cause the lag time to be shorter and the storm will be generated rapidly. That's all for me, thank you.
Hi everyone, I'm Tan Min Kai. Today I'll continue to explain a bit about the last comprehensive review, that is the unit hydrograph for estimating surface runoff and refining the water budget model of Meng Huan wetland. The figure A shows the location of Meng Huan wetland in Yangmingshan National Park. This study conducts hydrological investigation to establish a synthetic unit hydrograph SUH to estimate the surface runoff level and improve the water budget models at WBM of the Meng Huan wetland. Two methods are used in these study cases, that is, water budget model WBM and synthetic unit hydrograph SUH. Water budget models come from the hydrological survey. The water surface evaporation, elevation and precipitation, that is the WBM length dimension, and it can be calculated and obtained. The water budget models can minimize the residual water amount by rearranging them into each original water budget component. While the synthetic unit hydrograph of a basin for different duration can be derived by specific effective rainfall duration. The unit hydrograph is a linear model that can be used to derive the hydrograph that results from excess rainfall, and both formulas are shown as below. Next, we proceed to the result. The figure B shows the water surface elevation and precipitation data for the Meng Huan wetland in 2017. The Meng Huan wetland was relatively dry due to the lower precipitation level from July to September. Conversely, the water surface elevation increased because of the existence of heavy rainfall in October 2017, as shown in Figure B. In addition, we noticed that the precipitation intensity profoundly influenced the monthly average evaporation and water depth. In other words, the water depth increased with precipitation intensity. Figure C shows the monthly average and deviation of water depth, while Figure D shows the monthly total precipitation and evaporation depth. Figure C can shows the descending and ascending rate of water depth from the chosen pattern typhoon seasons. Rainfall brought seasonal and occasional heavy rain in late spring, while Figure D shows that the typhoon intensity and the amount influence the precipitation quantity in summer. Figure E shows the synthetic unit hydrograph of the Meng Huan wetland derived from averaging the hydrograph data for the 4 chosen rainfall event, while Figure F shows the flow hydrograph derived from the unit hydrograph and the total discharge measure from the gully runoff. In Figure E, the synthetic unit hydrograph SUH was derived from 4 chosen rainfall events. The peak value of the direct runoff histories for the 4 events range from 0.194 to 0.135 meter cube per second. The synthetic unit hydrograph shows that the precipitation event caused 6 hours of inlet surface runoff. We apply the SUH to an actual rainfall event in order to determine the amount of rain surface inflow. Figure F shows the phi index, that is the water loss index, total inlet surface runoff, and assess rainfall hydrograph of the water budget event on 20 January 2017. The data exposes and reveals the difference in the surface runoff discharge that were estimated from the synthetic unit hydrograph model and GSF model. When comparing the amount of these two results, we notice that the inlet surface runoff indicated by the GSF was much lower than that of the SUH. Hence, the residual term become much smaller. Table A shows the water budget residuals on 20 January 2017. By using the synthetic unit hydrograph SUH model and GSF method, in Table 1 we can notice that the simulation error of the two modes were considered very close. The result indicates that the residuals of 1D models and 3D water budget models were not significantly different. Besides that, the estimated surface runoff value was definitely the pivotal and the primary source of error in the model. Due to the amount of change of stored water was positive in the study cases, the total inlet were estimated and expected to be greater than the total outlet. After using the synthetic unit hydrograph SUH calculation, the residue error ratio of the water budget method WBM was decreased significantly from 293% to 34%. This was because the inlet surface runoff that was estimated by the water budget method included and contained overland flow as well as gully flow. Hence, we suggest that the synthetic unit hydrograph SUH to be used in order to reduce and decrease the water budget method's residual value and improve the accuracy of the estimated water budget. That's all from me, thank you. In conclusion, a hydrograph is a graphical representative as a runoff due to it change over time at a specific location, while the area under hydrograph is represented as the volume runoff. Based on Rosmalinda Permastari 2017, the most famous method to evaluate the flood discharge of an ungauged catchment area is by using synthetic unit hydrograph method. In the final result, the peak discharge that obtained from the unit hydrograph is approximate the same with the actual value, which is proven by simulation and the field data. A study about the deconvolution of the flood hydrograph at the outlet of the watershed Kolondiba in the south of Mali was done by D.A.O. Amido, Kamagate Bamori, Mariko Adama, Sigus Luz, Maiga Hamdon Bauka, Golia Bite Albert, and Savane Isyaka in 2012. After the investigation, they noticed that the rainfall availability at the interannual scale is wrongly influenced the result of deconvolution of the flood hydrograph at the watershed, which indicates that the rate of water compartment conducing to the runoff. Synthetic unit hydrograph SUH can be used to estimate the surface runoff level and improve the water budget model WBM, and the method has been applied in the Menghuan wetland in Taiwan. The total amount of the surface runoff can be estimated by using the synthetic unit hydrograph SUH, and the water budget method WBM can be refined. The entire surface runoff was determined and calculated by using the synthetic unit hydrograph SUH, and the result was approximately 2 times than that of the gully runoff survey. That's all from me. Thank you. From the result obtained on the journal article, which is about the rainfall threshold of the Catrium River flood for early warning on urban area by Arini Budi Safarina, Chaudhrina, Novita Sri Lestari Devi Aprirangish, Fatah Huda Muhammad Shahula, and Mutia Sadiq in 2021. The threshold rainfall in Bojangsang is the lowest, which indicate the Bojangsang is the most dangerous district for facing the flooding issue. According to Nova D. Sirai 2020, indicates the analysis of the base way for the peak discharge by using several methods such as synthetic unit hydrograph SUH. By referring the synthetic unit hydrograph of 3 different methods, it can be concluded that the Gamma 1 method is the most or the optimal synthetic unit hydrograph for calculating the maximum flood flow of the Bengawan Solo River in Denkeng Russo section. This is because the calculation result has the lowest error, which is 8.0, and it is closer to the on-site observation flow rate.